Roman road construction in Pompeii, a journey through ancient engineering. Welcome to this deep exploration of one of history's most fascinating engineering achievements, the roads of ancient Pompeii, where Mount Vesuvius erupted on that fateful day in August of 79 AD. It preserved not just buildings and bodies, but an entire infrastructure frozen in time. Beneath the ash and pumice lay streets that tell us an incredible story about Roman ingenuity, social organization, and daily life nearly 2,000 years ago. But before we dive into the details of how these roads were built, let's take a moment to appreciate the sheer luck of what we have in Pompeii. In most Roman cities, ancient streets have been built over, destroyed, or modified so extensively that understanding their original construction requires painstaking archaeological excavation and educated guesswork. In Rome itself, the continuous occupation and development over 2 millennia means that ancient streets survive only in fragments, if at all. The same is true in most cities throughout the Roman Empire. Pompeii is different. Here, volcanic catastrophe created an archaeological miracle. The eruption that killed thousands and destroyed a thriving city also preserved it in extraordinary detail. Buildings that would normally have been demolished and rebuilt, streets that would have been repaved or buried, infrastructure that would have been modified or destroyed. All of this survived because the city was abandoned and buried in a matter of hours. When excavations began in the 18th century, archaeologists found not ruins, but a preserved city, complete with all its details intact. This means that when we study Pompeian streets, we're not looking at fragments or reconstructions. We're looking at actual Roman infrastructure, preserved almost exactly as it was on the last day of the city's life. We can walk on the same stones Romans walked on. We can trace the same cart ruts their wheels created. We can examine drainage systems that still function in principle 2,000 years later. We can see stepping stones positioned exactly as Roman engineers placed them. This is an extraordinary gift to us, and it's one we should appreciate as we begin this journey. Today, we're going to walk these ancient streets together, examining every detail of how they were conceived, planned, and built. We'll meet the laborers who broke their backs lifting volcanic stone under the Italian sun. We'll understand the engineers who solved complex drainage problems without modern technology or mathematical calculations. We'll encounter the magistrates who oversaw construction, whose political careers might rise or fall based on whether streets flooded or remained passable. We'll discover the wealthy patrons who funded improvements for prestige and political capital. We'll learn about the materials used, where they came from, how they were processed, why basalt from Mount Vesuvius made such excellent paving stone. We'll understand the sophisticated engineering techniques that created multi-layer road structures designed to last for centuries. We'll follow the construction process from initial excavation through final paving, seeing how weather, politics, and human limitations shape timelines and outcomes. With fascination as workers transformed familiar streets, we'll understand the social and cultural meanings of roads, how they symbolized Roman civilization, how they reinforced social hierarchies, how they connected civic, religious, and commercial spaces into an integrated urban system. We'll examine the ongoing maintenance required to keep streets functional, the political accountability that ensured magistrates took infrastructure seriously, and the remarkable durability that allowed well-built streets to survive not just years or decades but centuries. We'll discover the unique features that made Pompeian streets distinctive, the stepping stones that allowed pedestrians to cross flooded streets, the cart ruts that still show us exactly where ancient traffic rolled, the narrow streets that controlled speed and noise. And we'll place all of this in the broader context of Roman engineering excellence, understanding how Pompeii streets fit into an empire-wide approach to infrastructure, how techniques spread across vast distances, how urban streets differed from military highways, and how Pompeii serves as our best preserved example of Roman urban planning. This isn't just a story about paving stones and ditches, about drainage channels and basalt blocks. It's a story about human ambition and achievement. It's about the price of progress and who pays it. It's about the incredible durability of well-executed craftsmanship. It's about the anonymous workers, whose names we'll never know, but whose work we can still walk on today. It's about the wealthy patrons who claimed credit for work they never did. It's about engineers solving problems through experience and observation, rather than theory and calculation. It's about cities as complex systems, where infrastructure shapes social life in profound ways. From the volcanic quarries, where basalt was cut to the final stone, laid perfectly in place. From the enslaved workers who received no credit to the wealthy patrons who claimed it all. Every street in Pompeii has 100 stories to tell. Some of those stories are inspiring, showing human ingenuity and skill at their finest. Some are troubling, revealing the brutal inequalities and human suffering that underlay Roman achievement. All of them are important if we want to truly understand not just how Romans built their cities, but what those cities meant to the people who lived in them. Over the next 3 hours, we're going to uncover these stories, examining 100 specific aspects of road construction in Pompeii. We'll move from the big picture, the planning and purpose of streets, down to the smallest details of how individual stones were fitted. We'll understand both the technical brilliance of Roman engineering and the human realities of ancient construction work. We'll see how streets shaped daily life, reflected social values, and created the framework within which ancient urban life unfolded. So settle in, get comfortable, and prepare to travel back in time. We're going to walk the streets of Pompeii as they were nearly 2,000 years ago, understanding them not as museum pieces or tourist attractions, but as living, functioning infrastructure that served a thriving city. We're going to meet the people who built these streets, used them, maintained them, and ultimately lost them to volcanic catastrophe. And we're going to appreciate the incredible accident of preservation that allows us, 2 millennia later, to study these streets in detail impossible almost anywhere else in the ancient world. To understand how roads were built in Pompeii, we must first understand what these roads actually were, and perhaps more importantly, what they were not. When most people think of Roman roads, they picture the great highways, the Via Appia, the Via Flaminia, those magnificent stone ribbons that connected Rome to the furthest reaches of its empire, carrying legions, merchants, and messages across thousands of miles. But the roads we're discussing today are something different entirely. Roads in Pompeii were primarily urban streets, not long-distance highways. They were the arteries and veins of a living city, pathways that saw thousands of footsteps every single day. Imagine yourself standing at a Pompeian intersection in, say, 70 AD. Around you flows the constant stream of urban life, a baker's slave hurrying to the market before dawn, a merchant leading a donkey laden with amphora of wine, a group of children darting between adults on their way to school, a litter carrying a wealthy matron to the baths, her bearers calling out for people to make way. This is what these streets were built for, the messy, vibrant, sometimes chaotic reality of city life. The city itself followed a grid-like plan influenced by Roman colonial design, and this is no accident. When Rome established colonies or reorganized existing cities, they brought with them a very particular vision of how a proper city should be arranged. This wasn't just practical planning, it was ideological. The Roman grid pattern, with its straight streets intersecting at right angles, represented order imposed upon the world. It was the same pattern used in military camps, where discipline and organization meant survival. In Pompeii, we can see this Roman vision made manifest in stone, though the city's earlier history and natural terrain meant the grid wasn't quite as perfect as in some newer colonial foundations. The streets were designed with multiple purposes in mind, and this is where the real genius of Roman urban planning becomes apparent. These roads had to accommodate pedestrians of all sorts. The wealthy strolling to social engagements, slaves running errands, beggars seeking alms, prostitutes soliciting clients, priests processing to temples. They had to handle carts of every description, from small hand carts pushed by vendors to large wagons hauling construction materials or agricultural produce from the countryside. They had to allow for the passage of animals, not just the donkeys and oxen pulling carts, but also livestock being driven to market, horses ridden by the occasional wealthy traveler, even the dogs and cats that populated every ancient city. But here's what many people don't realize. Perhaps the most important thing these streets had to handle was water. In a city without modern plumbing, in a climate that could see torrential rains followed by weeks of drought, water management was absolutely critical. Streets weren't just for transportation, they were part of an integrated water management system. During the heavy rains that could strike the Campanian coast, streets became rivers, channeling water away from buildings and toward drains. The street surface, the curbs, the slope of the pavement, all of these were calculated to move water where it needed to go and keep it away from where it would cause damage at a dead end. The position carried real responsibility and real accountability. But these streets were more than functional pathways, and this is something we need to understand if we're to truly grasp what road building meant in the Roman world. They symbolized Roman order, power, and civic pride in ways both obvious and subtle. Every street announced to residents and visitors alike that this was a Roman city, organized according to Roman principles. When a traveler from Gaul or Spain or Egypt arrived in Pompeii, they would immediately recognize the street pattern, the construction techniques, the whole organization of urban space. This was the visual language of empire, and it spoke clearly. Rome is here, and Rome is in control. Think about what it means when streets are straight and regular, when they're paved with durable stone, when water flows efficiently through drainage systems. It means someone is in charge. It means there's enough political stability for long-term planning. It means there's enough wealth to invest in public infrastructure. It means there's enough organizational capacity to coordinate complex construction projects. Every straight street was an argument for Roman rule, more effective than any speech or propaganda, because it was useful, visible, and undeniable. The width of roads wasn't determined by uniform standards, but rather depended on the importance of traffic that would flow through them. This is actually quite sophisticated urban planning. The main commercial streets, the ones connecting the Forum to the major gates, the routes that saw constant heavy cart traffic, these were built wide enough to handle the flow, but residential side streets could be narrower, just wide enough for pedestrians and the occasional handcart. This wasn't random. It was a deliberate allocation of resources and space. Every bit of street width represented valuable urban real estate that couldn't be used for buildings, so making streets wider than necessary was wasteful. But making them too narrow caused bottlenecks and traffic jams. The magistrates and engineers had to find the right balance. Main streets were deliberately aligned with city gates to control movement in and out of the city. This served multiple purposes. Practically, it made navigation simple. You could see from one gate straight through to another in some cases, making it easy for even first-time visitors to find their way. Militarily, it allowed defenders to see approaching forces and respond quickly. Commercially, it meant that goods coming in from the countryside could be quickly distributed to markets and shops. And symbolically, it created impressive sightlines. Imagine entering through the gate and seeing a straight, well-paved street stretching ahead of you into the heart of the city. It was impressive then, and the effect is still striking today. Roads also helped regulate commerce and market access, and this gave them real economic power. A shop on a main street could see 10 or 20 times more foot traffic than one tucked away on a side street. That meant main street locations commanded higher rents, which meant more revenue for property owners, which meant political influence. The layout of streets quite literally determined who became wealthy and who struggled. Magistrates deciding where new streets would go or which streets would be widened or improved were drainage, widen important routes. These weren't frequent events, maybe once in a generation for any given neighborhood, but when they happened, they transformed the urban landscape. Whole blocks might be reconfigured, new public spaces created, slums cleared and replaced with more substantial construction. And here's something fascinating that reveals much about Roman society. Wealthy patrons sometimes funded street improvements not out of pure civic duty, but for prestige. This practice, called euergetism, was a cornerstone of Roman civic life. A wealthy man, and it was almost always men, though occasionally wealthy women participated, might pay for a street to be paved or repaired, and in exchange, he would receive public recognition. Perhaps an inscription would be placed noting his generosity. Perhaps a statue would be erected in his honor. Perhaps he would simply bask in the gratitude of his fellow citizens. Gratitude that would translate to political support when he ran for office or needed public backing for some other endeavor. Having your name associated with a beautiful new street was a form of immortality. Long after you died, people would walk on the stones you paid for. They would see your name on inscriptions. They would tell stories about your generosity. It was a way to buy lasting fame and influence. And for the wealthy elite of Roman cities, it was money well spent. The city got infrastructure improvements it might not otherwise be able to afford. The patron got prestige and political capital. And the system kept working because both sides benefited. Now, who actually built these streets? The answer reveals one of the darker realities of Roman society. And it's a reality we need to confront honestly if we're to understand what these magnificent roads really represent. Laborers were often enslaved people or freedmen, people who had no choice in the matter and saw none of the glory. When we admire Roman engineering today, when we marvel at the skill and precision of ancient construction, we're looking at the work of people whose names we'll never know, whose lives were considered expendable, whose suffering was considered unremarkable. Slavery in the Roman world was fundamentally different from modern chattel slavery in some ways, but no less brutal. A slave might be a captured enemy soldier, a person sold to pay debts, someone born into slavery, or a child abandoned by parents who couldn't afford to raise them. Enslaved laborers on construction sites faced some of the harshest conditions imaginable. They worked from dawn to dusk, breaking stone in quarries, hauling massive blocks through streets, digging trenches through hard-packed earth, all under the Mediterranean sun. Yet among them, skilled stoneworkers were highly valued, and this reveals an interesting complexity in the system. Even within slavery, there was hierarchy. A man who could judge the quality of stone knew exactly where to strike to split a block cleanly, who could fit paving stones so precisely that no mortar was needed. Such a man had value beyond simple muscle power. A master might rent out a skilled enslaved worker to construction projects for substantial fees. That worker wouldn't see any of that money, of course, but he might be better fed, better housed, and less harshly treated than unskilled laborers. He might even hope to save enough money through tips or side work to eventually purchase his freedom. Organization. Legions built roads, bridges, fortifications, aqueducts, and entire camps with remarkable speed and standardization. When soldiers retired, those with construction experience often found work in civilian projects, bringing military discipline and techniques to urban building. They knew how to organize large labor forces, how to solve logistical problems, how to work quickly and efficiently. This cross-pollination between military and civilian construction meant that techniques developed on the frontiers of the empire quickly spread to cities like Pompeii. Make no mistake, this work was physically exhausting and dangerous. Imagine spending your entire day, every day, breaking stone with a hammer and chisel. Your hands would be masses of calluses and blisters. Your back would ache constantly from bending over stone blocks. Your lungs would be filled with stone dust, causing breathing problems that would only worsen over years. Your hearing would be damaged from the constant ringing of metal on stone. And this was just the quarry work. Actually, building roads meant hauling those stones, often for miles, then placing them with precision while crouching or kneeling on hard ground. Labor was organized into teams, each with specific responsibilities: quarrying, leveling, and paving. This specialization made sense from an efficiency standpoint. Not everyone needed to know every skill. You might have a team that did nothing but excavate streets, becoming incredibly efficient at that particular task. Another team might specialize in laying foundations, understanding exactly how to select and place stones for maximum stability. A third team might handle the actual paving, the skilled finish work that required a good eye and steady hands. These teams would move from project to project, becoming more proficient with each street they built. Foremen enforced discipline and pace, pushing workers to meet deadlines. These foremen occupied an interesting position. They were usually freedmen or slaves themselves, but they had authority over other workers. They might carry whips or rods as symbols of their authority, and they weren't hesitant to use them. A construction site that fell behind schedule reflected badly on the foreman, and the penalties for failure could be severe. So foremen drove workers hard, sometimes brutally hard. There was no concept of an 8-hour workday, no weekends off, except for religious festivals, no sick leave or vacation time. You worked until the job was done, or until you physically couldn't continue. Injuries were common, particularly from heavy stone lifting, and when we say common, we mean horrifyingly frequent. Crushed fingers and toes were almost routine. Backs were thrown out by improper lifting. Stones slipped from sweaty hands and fell on feet. Ropes snapped under strain, causing loads to crash down. Workers fell from scaffolding. Tools slipped and caused gashes that could become infected in an era before antibiotics. And there was no formal safety equipment of any kind. No hard hats, no steel-toed boots, no safety harnesses, no protective eyewear. Workers wore whatever clothes they owned, probably a simple tunic and maybe sandals, though many likely worked barefoot because shoes wore out and were expensive to replace. The medical care available was rudimentary at best. A serious injury likely meant death or permanent disability. Even minor injuries could become infected and lead to blood poisoning. There was no workers' compensation, no disability payments. An enslaved worker who became too injured to work was a loss to his owner, but the worker himself had no recourse. A free laborer who couldn't work couldn't eat. The human cost of Roman. Familiar with basic construction work even today. A pick for breaking up hard ground or stone. Hammers of various sizes for different tasks. Small ones for detail work. Large sledgehammers for breaking stone. Levers for moving heavy objects, using mechanical advantage to shift weight no human could lift directly. These were tools that had been used for thousands of years before Rome and would continue to be used for thousands of years after. They were simple, durable, and effective, but they were also entirely human-powered. Every bit of work required human muscle, human sweat, human effort. Payment varied dramatically depending on your status. Some workers were unpaid slaves who received only food, clothing, and shelter, the bare minimum to keep them alive and working. But not all construction workers were enslaved. Free laborers, often poor citizens or foreigners, worked for daily wages. These wages were enough to survive on, but just barely. A day's wage might buy enough grain to feed a family for a day, maybe two if you were careful. There was no saving for the future, no financial security. You worked, you ate. You didn't work, you went hungry. This precarious existence meant that construction work, despite its hardships, was actually desirable employment for the urban poor. It was brutal, but it was steady work, and steady work meant survival. Freedmen, former slaves who had gained their freedom, occupied an interesting middle ground. They weren't slaves anymore, but they also weren't full citizens with all the rights and protections that entailed. Many freedmen continued to work in the same trades they'd practiced as slaves, including construction work. Their experience made them valuable, but their status meant they could be exploited more easily than full citizens. They might work for lower wages than citizen laborers or face worse conditions, but they had one advantage slaves didn't have: the ability to refuse. If conditions became truly intolerable, a freedman could, in theory, walk away and seek work elsewhere. It might mean starvation, but the choice existed, and that choice mattered. The materials: stone from fire. Let's talk about the materials themselves, because the story of Pompeii's roads begins deep underground, in the molten heart of the earth. The primary paving stone was basalt, also known as lava stone, and this is a material with a story as dramatic as the city itself. Basalt is igneous rock, born from fire, created when molten lava cools and solidifies. It's incredibly hard, resistant to weathering, and has a texture that provides excellent traction even when wet. In other words, is nearly perfect for paving roads. But it's also difficult to work with precisely because of that hardness. Cutting and shaping basalt requires patience, skill, and tools that can withstand the punishment. This basalt was sourced locally from volcanic areas near Mount Vesuvius, making it both available and appropriate for the region's geological conditions. The same volcano that would eventually destroy Pompeii also provided the material that built it. There's a dark irony in that, isn't there? The mountain that loomed over the city, that appeared in paintings and mosaics, that was simply part of the landscape for Pompeians. That mountain gave them the stone for their streets before it buried those streets under ash and pumice. The quarries themselves were brutal places. Imagine standing at the edge of a basalt quarry in ancient times. Might heat the rock face with fire and then douse it with cold water, causing thermal shock that would fracture the stone. Once large blocks were freed, they had to be moved, rolled, dragged or carried using wooden sledges and rollers. Stone blocks were cut roughly, not perfectly uniform. And this is an important point. We sometimes imagine ancient stonework as being precisely cut with laser-like accuracy, but that wasn't how it worked. Basalt was cut to approximately the right size and shape in the quarry, then further refined at the construction site. The blocks weren't identical. They varied in size, sometimes significantly. This meant that laying them required skill and judgment. You couldn't just place them in a predetermined pattern. Each stone had to be selected for where it would fit best, sometimes trimmed or adjusted, fitted like a three-dimensional puzzle. Smaller stones were used for the road foundation, providing a stable base for the layers above. These weren't the beautiful, dark basalt blocks that formed the street surface. These were rougher stones, fragments, rubble, the less attractive pieces from the quarry, broken bits, whatever was available and affordable. Size mattered more than appearance for foundation work. The stones needed to lock together, creating a stable mass that wouldn't shift under load. Workers would pack these foundation stones tightly, sometimes hammering smaller fragments into gaps to eliminate voids. Lime mortar was used sparingly in road construction, not nearly as much as in wall building. This is interesting, because it shows the Romans understood that roads and buildings have different structural requirements. In a wall, mortar binds stones together into a monolithic structure. But in a road, you actually want some flexibility. A road surface experiences constant stress from traffic and temperature changes. If stones are too rigidly bound, together cracks will propagate through the entire surface. But if stones can shift slightly, independently, the stress is distributed and localized damage doesn't spread. So Roman road builders used mortar minimally, primarily in the deeper layers where it helped with drainage and stability, not in the surface paving where flexibility was beneficial. Wood served temporary purposes, used for scaffolding and rollers to move heavy stones. The ancient world ran on wood in ways we sometimes forget. Every major construction project required enormous amounts of timber for scaffolding that allowed workers to reach high places, for ramps that let them move materials to different levels, for rollers that let them move weights far beyond what humans could carry, for levers that multiplied force, for frames that held structures in place while mortar set. This wood was valuable and expensive, so it was reused from project to project until it literally fell apart. A construction site would have piles of lumber in various states of wear, some pieces still strong and useful, others splintered and suitable only for firewood. Iron tools were expensive and carefully maintained. Losing or breaking one could mean delays and punishment. Iron in the ancient world was nothing like the cheap, abundant steel we have today. It had to be smelted from ore hammered by blacksmiths, carefully shaped and tempered. A good hammer or chisel represented hours of skilled labor and significant expense. Tools were assigned to individual workers or to work gangs, and those tools had to be accounted for. Losing a tool might mean a beating for a slave or a wage deduction for a free worker. Breaking a tool through carelessness or misuse was a serious offense. Workers. Where the roadway ended, they helped channel water, preventing street runoff from flooding sidewalks or building entrances. They provided a physical barrier that helped protect pedestrians from traffic. And they added a finished, orderly appearance to the street. Installing curbs required precision. They needed to be at a consistent height, properly aligned, securely anchored. Often, curbs were set before the street was paved, providing a fixed reference point for the paving work. Raised sidewalks, called crepidines in Latin, were built alongside roads for pedestrian safety. These sidewalks were typically raised 6 to 12 inches above the street level, high enough that pedestrians didn't have to wade through mud, water, or worse, when crossing or walking alongside streets, but not so high that stepping up became difficult. The sidewalks were usually paved with less expensive stone than the street itself. Sometimes the same basalt, but rougher cuts, sometimes limestone or other local stone. Building these sidewalks was its own skilled trade, requiring proper foundations, drainage considerations, and connections to building entrances. And in true Roman practicality, materials were often reused from older buildings when possible, recycling what earlier generations had quarried. This wasn't just frugality, though that was certainly part of it. It was also pragmatism. Why expend the effort to quarry new stone when usable stone already existed? Old buildings were demolished, temples were rebuilt in new styles, houses were renovated, and all that stone had to go somewhere. Some of it ended up in foundations, buried where appearance didn't matter. Some was broken up for rubble fill. The best pieces might be recut and reused in new construction. Archaeological excavations in Pompeii have found street repairs made with reused architectural elements, column drums, broken sculptures, old paving stones from elsewhere in the city. Every stone had value, and waste was minimized. Engineering brilliance, the science of layers. The engineering techniques behind these roads were remarkably sophisticated, representing centuries of accumulated knowledge about how to build structures that would last. This wasn't theoretical knowledge written in treatises, though a few Roman authors did write about construction. This was practical, hands-on. Understanding developed through trial and error across generations. Roads were built in layers for durability, each layer serving a specific purpose in the overall structure. This multi-layer approach is actually quite brilliant when you think about it. A single thick layer of stone would be enormously heavy, difficult to work with, and prone to catastrophic failure. If a crack developed, it could split the entire road. But multiple layers distribute stresses differently. They allow for drainage between layers. They let you use different materials for different purposes. And they mean that damage tends to be localized rather than spreading through the entire structure. The lowest layer, called the statumen, used large stones to create a stable foundation. Picture this. Before any paving could begin, workers would excavate the street down to stable ground, sometimes several feet below the desired final street level. Then they'd begin placing the statumen stones, large, rough pieces of rock, sometimes the size of a human head, or even larger. These didn't need to be beautiful or uniform. They needed to be strong and stable. Workers would place these stones carefully, fitting them together like a stone mosaic, making sure there were no large voids where the layer could collapse or shift. Sometimes they'd hammer smaller stones into by previous construction. In areas with poor soil conditions, the statumen might be particularly thick and carefully constructed. In areas with bedrock close to the surface, it might be thinner. Roman engineers adjusted their techniques based on local conditions. Above the statumen came a gravel and rubble layer known as the rudus, which helped with drainage and weight distribution. This is where Roman understanding of water management really shows. The rudus layer wasn't just structural, it was hydraulic engineering. Water that seeped through the upper layers of the road, whether from rain or from street cleaning, or from the various liquids that inevitably got spilled on city streets, needed somewhere to go. If it stayed trapped in the road structure, it would freeze in winter and expand, cracking the layers above. Or it would soften the foundation, causing settling and collapse. The rudus layer allowed water to percolate through and drain away. It was typically made of broken stone, gravel, and rubble, materials that would pack together but still have spaces between particles for water to flow through. Workers would spread this layer, then compact it by tamping or rolling, creating a dense but permeable mass. The thickness of the rudus layer varied depending on local conditions. Deeper in areas with more water, shallower where drainage was less of a concern. Then came a finer layer called the nucleus that helped level the surface, preparing it for the final layer. Think of the nucleus as the transition between the rough, utilitarian lower layers and the finished visible surface. This layer used smaller materials, fine gravel, sand, small stone fragments. It was carefully leveled and compacted, creating a smooth, even surface. Any irregularities in this layer would telegraph through to the paving stones above, creating an uneven street surface. So the nucleus had to be precisely done. Workers would spread the nucleus material, then use long straight edges, probably wooden boards or metal bars, to check the level. They'd add material where the surface was too low, scrape away where it was too high. Then they'd compact it all, either by tamping with hand tools or by rolling heavy stone rollers over it. The goal was a surface that was not only level, but also firm enough that the paving stones above wouldn't sink or shift. This required judgment and experience. Too loose, and the surface would compress under load. Too compact, and it might not drain properly. The best workers knew exactly what the texture should feel like underfoot, how it should sound when struck with a tool. The top layer was the summa crusta, the fitted paving stones that people actually walked and drove carts over, the surface that we can still see today in the streets of Pompeii. This was where the real artistry came in. The basalt paving stones, each one weighing perhaps 50 to 100 pounds or more, had to be individually placed, fitted, and secured. Each stone was different, slightly different in size, slightly different in shape. Workers had to look at each stone, decide where it would fit best, sometimes trim it with hammers and chisels to improve the fit, then maneuver it into position. The stones were fitted so tightly together that little or no mortar was needed. This tight fitting served multiple purposes. It created a smooth surface that was easy to walk on and that wouldn't catch cartwheels. It prevented stones from shifting under the constant pounding of traffic. It minimized gaps where water could penetrate or debris could accumulate. And it demonstrated skill. A well-paved street with tight joints was a mark of quality. Here's a detail that shows real engineering insight. Roads were built slightly convex, higher in the middle than at the edges, to shed water toward the sides. If you look at a cross-section of a Roman street, you'll see it's not flat. It's crowned, rising perhaps 6 inches or more from the curb to the center line in a major street. This crown, or camber, is essential for water management. When rain falls on a flat surface, water puddles. When it falls on a crown surface, it flows to the sides. In a city that could see torrential downpours, this simple geometrical feature made the difference between functional streets and impassable quagmires. Creating this crown required careful planning and skilled execution. The foundation layers had to be built with the crown already in place. You couldn't just make the surface curved and expect it to hold. Every layer, from the statumen up through the nucleus, had to be higher in the center than at the edges. Workers had to constantly check the cross-sectional profile, making sure the crown was consistent and would result in proper drainage. Too much crown and carts would tend to slide toward the edges. Too little and water wouldn't drain effectively. The optimal crown was just right, enough to move water, but not enough to affect traffic. Drainage was, in fact, a major engineering priority in a city that could see torrential Mediterranean rains, followed by weeks of drought. Roman engineers understood something that modern city planners still struggle with. Water management is infrastructure. Good drainage isn't a luxury or an afterthought. It's essential to everything else working properly. Flooded streets meant disrupted commerce, damaged goods, public health hazards, and structural damage to buildings. So enormous effort went into making sure water flowed where it was supposed to go. Gutters ran along sidewalks, channeling water away from the street surface toward collection points and drains. These gutters were carefully shaped and positioned. They had to be deep enough to carry water, but not so deep that they became traps for cartwheels or pedestrian hazards. They had to slope consistently toward drains. Too steep, and water would flow too fast and potentially cause erosion. Too shallow, and it would pool. The gutters were often lined with fitted stones, creating smooth channels that wouldn't degrade from water flow. Streets were cleverly connected to underground drainage systems that carried water out of the city and eventually to the sea or to agricultural fields, where it could be used for irrigation. These drainage systems were themselves major engineering works, underground channels, often large enough for a person to crawl through for maintenance, built with the same careful attention to slope and construction as the streets above. They had to be strong enough to support the weight of streets and buildings above them. They had to be watertight enough that water flowed through them, rather than leaking into surrounding soil. And they had to be maintainable, with access points where workers could clear blockages. What's remarkable is that engineers relied on experience and observation, not written blueprints or mathematical calculations. There was no blueprint for a Roman street in the way we understand blueprints today. No detailed drawings showing every dimension and every material. Instead, the master builder would understand the principles, would have built enough streets to know what worked, and would direct the work based on that experience. He'd walk the site, feeling the soil under his feet, observing how water flowed, considering the traffic patterns, and then make decisions about how deep to excavate, how thick each layer. Aspects of road construction, able to judge by eye what less experienced workers needed instruments to measure. The best builders developed an almost intuitive sense for how a road should be built, reading the land and the materials and making hundreds of small decisions that together resulted in streets that would last for centuries. All of this knowledge was vulnerable, though. It existed in minds and hands, not in books. If experienced builders died without passing on their knowledge, it could be lost. If economic conditions made major construction projects rare, young workers might not get the training they needed. The continuity of knowledge depended on continuous practice, on each generation teaching the next, on communities maintaining the tradition of quality construction. When that continuity broke down, as it eventually did across the empire, the knowledge faded, and later generations couldn't reproduce what their ancestors had built. The construction process, from earth to stone. The actual construction process was an elaborate undertaking that transformed neighborhoods and disrupted city life for weeks or months at a time. To truly understand what road construction meant in ancient Pompeii, we need to imagine ourselves there, witnessing the process from beginning to end. It all began with excavation. Streets were excavated before any construction could begin, with crews digging, down to stable ground. But before even the first shovel of earth was turned, there would have been planning meetings. Magistrates would meet with experienced builders to walk the route, discuss the scope of work, estimate costs and time. They'd consider what other work might be coordinated with the road project. Perhaps this was a good time to repair or extend underground drainage, to replace water pipes, to remove old building foundations that protruded into the street line. Once the decision was made to proceed, the disruption began. Existing traffic had to be rerouted or halted entirely, causing significant inconvenience and economic impact. Imagine being a shop owner on a street slated for reconstruction. One day, magistrates' representatives appear and inform you that the street outside your shop is going to be torn up for the next several months. Your customers won't be able to reach you easily. Deliveries will be complicated or impossible. The noise and dust will drive away anyone who does try to visit. Your income is about to drop dramatically, and there's nothing you can do about it. For the city as a whole, traffic patterns had to be reorganized. People who normally use the affected street for their daily routines had to find alternative routes. Cart traffic, the lifeblood of urban commerce, had to be diverted. This might double travel times for some routes, creating bottlenecks elsewhere in the city. The ripple effects of road construction extended far beyond the immediate work site. The excavation itself was grueling work. Workers would begin by marking out the street line, probably using wooden stakes and string to define the edges. Then the digging would start. In some places, they'd be removing relatively loose fill from previous construction. In others, they'd be cutting through hard-packed earth or even rock. The excavation had to go deep enough to reach stable ground, which might be 2 feet or might be 6 feet or more, depending on local conditions and the history of previous building on the site. Fragments, coins, trash that had been buried and forgotten. Sometimes they'd encounter unexpected obstacles, large rocks that had to be broken up or moved, old drainage channels that had to be dealt with, areas where previous construction had left voids that now needed to be filled. The foreman had to make constant decisions about how to handle what they found, sometimes consulting with the magistrates if the issue was significant. All the excavated material had to go somewhere. In a modern city, we'd load it into dump trucks and haul it to a landfill. In ancient Pompeii, they had to use baskets, carts, and human labor. Workers would load excavated soil into baskets, carry or cart it to disposal sites, probably low-lying areas outside the city that needed filling, or perhaps to agricultural areas where soil was needed. This meant a constant stream of workers and carts moving to and from the site, adding to the disruption and the logistical complexity. Construction timelines could extend from weeks to months, depending on numerous factors. A short residential street with good underlying conditions might be completed in a few weeks if the work gang was large and experienced and weather cooperated. A major commercial street, especially one requiring extensive drainage work or dealing with difficult conditions, might might take many months. And these timelines were measured in working days, not calendar days. Festivals, religious obligations, and bad weather all stopped work. Progress depended heavily on weather conditions, and the Mediterranean climate presented both advantages and challenges. The region's relatively mild winters meant that construction could potentially continue year-round, unlike in more northern parts of the empire where hard freezes would halt work for months. But the climate also brought challenges that significantly affected construction schedules. Summer heat made labor especially harsh, with workers toiling under the Mediterranean sun in conditions we would consider dangerous today. Picture a midsummer day in Pompeii, temperature in the mid-90s Fahrenheit or higher, the sun beating down relentlessly from a cloudless sky. Workers would start at first light, trying to get as much done as possible before the heat became unbearable. By midday, the pace would slow dramatically. Men would be drenched in sweat, struggling with heat exhaustion. Water breaks would become more frequent and longer. Productivity would plummet. The stone itself would become almost too hot to touch. Metal tools would heat up, making them painful to hold. The dust kicked up by construction work would hang in the still air, making breathing difficult and coating everyone in a layer of grit. Workers might seek whatever shade they could find during the worst heat of the afternoon, huddling under makeshift shelters or in the shadows of buildings. Work might resume in the late afternoon as temperatures dropped slightly, continuing until darkness made it too dangerous to continue. Heat wasn't just uncomfortable, it was dangerous. Heat stroke, dehydration, and exhaustion would claim workers every summer. An enslaved laborer who collapsed from heat might be left to recover on his own if he was lucky, or might simply be replaced if his owner decided he wasn't worth the trouble. A free worker who couldn't continue working didn't get paid. The economic pressure to keep working despite dangerous conditions was intense. But summer had one advantage. Work could proceed continuously. Rain could delay stone setting, turning work sites into muddy chaos. The autumn and winter rains that replenished the region's water supply and enabled agriculture were a nightmare for road construction. A major rainstorm could halt work for days or even weeks. The excavated street bed would fill with water, turning into a canal. The carefully prepared layers of the road foundation would be saturated, potentially disrupting the compaction and grading that had been done. Mortar, if used, couldn't be placed during wet weather. It wouldn't cure properly. Stone paving couldn't be fitted when everything was slick with mud. Workers couldn't maintain their footing on slippery surfaces. The entire construction site would become a dangerous, unworkable quagmire. After a storm passed, days might be spent just draining the work site, allowing materials to dry out, and repairing damage that water had caused. So construction schedules had to account for weather patterns. The ideal time to build roads was probably late spring or early autumn, after the winter rains but before summer heat became unbearable, or after summer heat broke but before winter rains began. But cities couldn't always wait for ideal conditions. Sometimes urgent repairs had to be made in less than perfect weather. Sometimes political considerations demanded that a project be completed quickly, regardless of season. The physical process of moving materials was itself a major undertaking. Stones were moved using rollers and ramps, techniques that were simple in concept, but required skill and coordination in practice. Picture a paving stone weighing 100 pounds or more, too heavy for any one person to carry any distance, awkward in shape, unforgiving of mistakes. Workers would maneuver such stones using wooden rollers, cylinders of hard wood that would be placed under the stone, allowing it to be rolled rather than carried. This required teamwork and timing. Several workers would coordinate their efforts, lifting one edge of the stone to get rollers underneath, then pushing or pulling the stone forward. As it rolled off the back roller, someone would grab that roller and move it to the front, creating a continuous track. It was slow, but it worked, allowing small teams to move weights that would otherwise be impossible. For moving stones up ramps or onto the road surface, teams would coordinate their lifting efforts with ropes and levers. Ropes would be tied around or under a stone, with multiple workers hauling together. The timing had to be precise, everyone pulling at once, maintaining tension, moving together. A rope under uneven load could snap, sending the stone crashing down and potentially killing or maiming workers. A worker who lost his grip could cause others to lose theirs, creating a cascade failure. Levers allowed workers to multiply their force. A long wooden beam positioned under a stone and braced against a fulcrum could let 2 or 3 workers lift weights that would normally require a dozen. But levers required skill to use properly. The fulcrum had to be positioned correctly. The lever had to be strong enough to take the strain. Workers had to apply force at the right point and in the right direction. Experienced workers developed an instinct for this, understanding the mechanics of leverage in a practical, hands-on way, even if they couldn't explain the mathematical principles involved. It required precise timing and communication. One person losing their grip could injure everyone in the chain. This meant that work gangs that worked together regularly developed their own rhythms and communication. Systems, calls and responses, warnings shouted in the din of construction, hand signals for coordinating lifts. A good foreman knew his crew's capabilities and limitations, knew which workers could be trusted with the most critical tasks, knew how to organize the work for maximum efficiency and minimum risk. Once stones reached their position in the street, paving stones were fitted tightly to prevent shifting under the weight of loaded carts. This was skilled work, requiring a good eye and a feel for how stones would behave under load. A worker would place a stone, step back and look at how it sat. Maybe try shifting it slightly to improve the fit with surrounding stones. He'd check for wobbling, a stone that rocked when stepped on wood. Sometimes a stone would need trimming, too large in one dimension, or with a protrusion that prevented a good fit. The worker would mark where material needed to be removed, then carefully chip away at the stone with a hammer and chisel. Too aggressive and the stone might split. Too cautious and he'd waste time. The skill was in knowing exactly how hard to strike, where to aim, how the stone would fracture. This knowledge came only through experience, through having shaped hundreds or thousands of stones, through having learned by trial and error what worked. Final leveling was done by eye, not precision tools. The skilled workers knew what looked right and what would function properly. They'd crouch down and sight along the street surface, looking for irregularities. They'd pour water on the surface and watch how it flowed, making sure it moved toward the gutters as intended. They'd walk on the newly paved surface, feeling for unevenness underfoot. They'd drive test carts over it, listening for rattling that might indicate loose stones. This empirical testing was how quality was assured. There were no engineers with levels and transit certifying that the work met specifications. There were no inspectors with checklists. There was just the experienced eye of the master builder and the pride of workers who knew that their work would be judged by how well it held up. Over the years, a poorly built street would develop problems quickly, stones working loose, drainage failing, the surface becoming rutted and uneven. And everyone would know who had built it. A well-built street, though, would last for generations, becoming part of the permanent fabric of the city. It would see countless thousands of footsteps, wheels and hooves. It would weather storms and earthquakes, and if built well, it would endure. That was the goal, and the best builders achieved it. The streets of Pompeii, that we can walk on today, 2,000 years later, are testament to the skill of those anonymous workers who fitted each stone by hand and eye, who judged drainage by pouring water and watching it flow, who knew their craft so well they could build for the ages without modern tools or technology. All of this construction had profound impacts on daily life in Pompeii, effects that rippled through every aspect of urban existence. To really understand what this meant, we need to step into the sandals of Pompeii's residents and experience street construction from their perspective. Construction disrupted nearby shops and homes, sometimes for months at a time, fundamentally altering the rhythm of entire neighborhoods. Imagine you're a potter with a shop on a street that's being rebuilt. Your business depends on customers being able to reach you, on people walking past your shop and seeing your wares displayed. Now that street is torn up, a trench 2 or 3 feet deep, running its entire length. The sidewalk where you normally display finished pieces is now a pile of excavated earth and broken stone. Customers who used to walk past every day now take a different route to avoid the construction. Your income drops immediately and dramatically. Maybe you're losing half your daily sales, maybe more. But your expenses don't drop. You still have to pay rent on your shop. You still have to buy clay and fuel for your kiln. You still have to eat and feed your family if you have one, and pay your slaves or workers if you employ any. The financial stress builds day by day, week by week. You might have to take out loans to survive. Loans. And it's not just the lost sales. The noise from stone cutting echoed through streets, making normal life nearly impossible. From first light until dusk, the air would be filled with the constant ringing of metal on stone. Hammers striking chisels, chisels striking rock, the sharp crack of stone splitting, the rumble of heavy stones being moved. Conversation became difficult. You'd have to shout to be heard over the din. Sleep became disrupted, especially for those whose homes or shops backed onto the construction site. Afternoon rest periods, a common practice in Mediterranean cultures to escape the heat of the day, became impossible. For people trying to conduct business, the noise was maddening. Trying to negotiate a price with a customer while hammers rang and stones crashed in the background. Trying to concentrate on craft work, painting pottery, writing documents, conducting business accounts with constant distraction. The psychological toll of months of unrelenting noise shouldn't be underestimated. It wore people down, frayed tempers, contributed to stress and conflict. Dust was constant during dry periods, coating everything and everyone within blocks of the worksite. Every blow struck against stone created a cloud of fine particles. Every basket of excavated soil dumped produced dust. Every stone rolled along the ground kicked up grit. And in the dry season, with no rain to settle the dust, it would hang in the air, drifting on any breeze, infiltrating every crack and opening. This dust got everywhere, inside homes and shops, coating furniture, contaminating food, irritating eyes and throats. Textile merchants would find their fabrics filmed with grit. Food vendors would struggle to keep dust out of their products. Residents would sweep their homes and shops multiple times daily, fighting a losing battle. Against the constant infiltration, People developed coughs from breathing the dust. Those with respiratory problems suffered terribly. The dust was particularly problematic for certain businesses. A physician trying to treat patients in a dust-filled room. A scribe trying to keep documents clean. A food seller trying to maintain any semblance of hygiene. These businesses might see customers go elsewhere, to parts of the city not affected by construction, further compounding the economic impact. Residents complained, but they had little political power to halt projects once magistrates had approved them. There might be formal complaints brought before magistrates in public meetings. There might be informal grumbling in the baths or forum. But in Roman society, authority was concentrated in the hands of a relatively small elite. Common residents, shopkeepers, artisans, laborers. These people might represent the majority of the population, but they had limited ability to influence major civic decisions. Magistrates who had committed to a road project, especially if a wealthy patron was funding it, were unlikely to halt or delay the work just because residents were suffering. This didn't mean residents were entirely without recourse. They could make their displeasure known in ways that might matter to politicians. They could withhold their votes or support in future elections. They could start or spread rumors damaging to a magistrate's reputation. They could protest loudly and publicly, creating embarrassment. But ultimately, once construction was underway, it would continue until completion regardless of resident complaints. Merchants, meanwhile, depended on quick completion since closed streets meant closed businesses, and they might use whatever influence they had to pressure for faster work. A merchant with good connections might arrange a meeting with the relevant magistrate, arguing that the construction was taking too long, that his business was suffering, that the city owed him consideration. A group of merchants might band together, presenting a collective appeal for the work to be expedited. They might even offer inducements, contributions toward construction costs in exchange for prioritizing their street. Sometimes these efforts worked. A politically connected merchant might get his concerns addressed, but more often, construction proceeded at its own pace, driven by the realities of labor availability, weather, materials supply, and the complexity of the work itself. Merchants who couldn't afford the income loss might close their shops temporarily, perhaps moving inventory to locations elsewhere in the city. Those who stayed open suffered through the lean months, hoping their customers would return when construction finished. To help mitigate the impact, temporary walkways were sometimes installed to maintain some foot traffic, though these were crude and often dangerous. Planks might be laid across the excavation, creating narrow bridges that people could use to cross. Ramps might be constructed at intersections, allowing access to cross streets. These temporary structures were just that, temporary. They weren't built to last or to be particularly safe. A plank might be slick with mud or dust. A ramp might be steep and difficult to navigate, especially for the elderly or those carrying loads. People used these walkways because they had no choice, but they did so carefully. Falls were common. Loads were dropped into the excavation below, sometimes damaged or lost entirely. The makeshift walkways were especially problematic during rain, when wet wood became treacherously slippery. But without these walkways, neighborhoods would have been completely cut off, so despite the hazards, they were necessary. Animals avoided construction zones when possible, adding to traffic problems in adjacent streets. Donkeys and oxen, the primary draft animals in Roman cities, are generally smart enough to be wary of unstable ground and unexpected obstacles. An animal that regularly used a particular route would balk when that route suddenly became an obstacle course of trenches, piles of materials, and unfamiliar noises. Handlers would drive their animals through construction zones, a process that slowed traffic and sometimes simply wasn't worth the effort. So carters and handlers would seek alternative routes, which meant that streets parallel to the construction site might see double or triple their normal traffic. This created new bottlenecks and congestion. It increased wear on streets that might not have been designed for heavy traffic. It brought noise and disruption to neighborhoods that had previously been quiet. The ripple effects of construction extended far beyond the immediate work site. Children watched the work with fascination and sometimes helped informally, carrying water or small tools, their involvement reflecting both the harsh economic realities of ancient life and children's natural curiosity. For a child from a poor family, hanging around a construction site might mean a chance to earn a few coins running errands, carrying messages, fetching tools or materials from storage. The money would be minimal, but every bit helped. And for children generally, watching skilled workers build something substantial and permanent was endlessly fascinating. But construction sites were dangerous places for children. Falling stones, sharp tools, moving carts, all posed serious hazards. Foremen would chase children away when they got too close to the actual work. But children being children, they'd creep back, watching from the edges, sometimes getting closer than they should. Injuries to children on construction sites must have been fairly common, though they rarely made it into historical records unless a child from a wealthy family was involved. Street vendors had to adapt to changing foot traffic, moving their stalls day by day to follow the crowds. A vendor who normally set up on a particular corner because foot traffic was good, there might find that. Construction had diverted all the traffic elsewhere, so he'd pack up his stall and move, trying to figure out where people were walking now, setting up in a new location. But that location might already have other vendors, might be claimed by someone else, might lead to conflicts over space. Vendors selling perishable goods, fresh fish, fruits, vegetables, prepared foods, were especially vulnerable. They couldn't easily store inventory from one day to the next, couldn't wait out the construction. Every day they had to sell what they had or lose it to spoilage. Construction that disrupted their normal customer base could be financially devastating. A fish vendor who couldn't sell his catch would watch it rot, representing a total loss of his investment. But when work finally finished, completed roads improved property values in the neighborhood, making the disruption worthwhile for property owners, if not for tenants. A street that had been deteriorating, becoming difficult to navigate, flood-prone, perhaps even dangerous, was now fresh, level, well-drained. Buildings fronting on that street became more desirable. Shops could command higher rents. Residential properties could fetch better prices if sold. For landlords and property owners, road construction was an investment that paid dividends. For tenants, though, the calculation was different. They'd suffered through months of disruption, but might not benefit from the improvement. Indeed, they might find their rent increased to reflect the property's enhanced value, forcing them to move elsewhere. The benefits and burdens of infrastructure improvements were not distributed equally across Roman society, just as they aren't today. Those with property wealth captured much of the benefit. Those without property, the poor, the tenants, the marginalized, bore much of the burden while enjoying fewer long-term advantages. Social and cultural dimensions. Roads as social statements. The social and cultural dimensions of road construction ran deep, touching on fundamental questions about who held power in Roman society, what values Romans held dear, and how the physical infrastructure of a city both reflected and reinforced social relationships. Roads were powerful symbols of Roman civilization, physical manifestations of order imposed on the landscape. To understand this symbolism, we need to step back and consider what Rome meant in the ancient world. Rome wasn't just a city or even an empire. It was an idea, a way of organizing the world that Romans believed was superior to all alternatives. Romans saw themselves as bringing civilization to chaos, order to. Generations of use, winding around obstacles, following the contours of terrain, muddy in wet weather and dusty and dry. Rome came and imposed a different vision. Straight streets, paved with fitted stone, properly drained, built to last centuries. This wasn't just practical infrastructure. It was an argument made in stone and mortar. It said, the Roman way is better. Roman engineering is superior. Roman organization brings benefits that no other system can match. When provincial cities throughout the empire built Roman-style roads, they were doing more than just improving transportation. They were signaling their acceptance of Roman civilization, their participation in the Roman order, their identity as part of something larger than themselves. The roads connected them physically to Rome, but more importantly, they connected them culturally and ideologically to what Rome represented. In Pompeii, these symbolic dimensions would have been clearly understood by everyone. When a new street was completed, when citizens walked on smooth paving stones instead of muddy earth, when water drained efficiently instead of pooling in stagnant puddles, they would have felt pride in their city's participation in Roman civilization. They were citizens of Rome, or at least subjects of Roman rule, and their streets proved it. Inscriptions sometimes commemorated road donors, ensuring that wealthy benefactors received lasting recognition for their generosity. These inscriptions were carefully crafted, usually in Latin, often following conventional formulas. They might note the name of the donor, his official positions or honors, and the nature of his contribution. For example, Marcus Aurelius Festus, Duovir, paved this street at his own expense for the honor of the colony. Such inscriptions served multiple purposes. Most obviously, they ensured that the donor's name and generosity would be remembered long after he died. Walking down the street, reading the inscription, people would recall Marcus Aurelius Festus and think well of him. This wasn't vanity, or not only vanity, it was an investment in social capital. A family whose name was associated with civic benefactions would find their political influence enhanced, their social status elevated, their ability to arrange advantageous marriages for their children improved. But inscriptions also served a didactic purpose. They taught citizens what was valued in Roman society: generosity, civic duty, personal expenditure for public benefit. These were virtues that inscriptions celebrated. Young men from wealthy families seeing these inscriptions would understand what was expected of them if they wanted to achieve honor and recognition. The inscriptions were lessons in proper elite behavior, carved in stone for all to see. The entire process of road construction reinforced social hierarchies in unmistakable ways. At every stage, who did what work, who made what decisions, who received what credit, all of these reflected and reinforced the deep social divisions of Roman society. Elite citizens avoided manual labor entirely, observing from a distance or simply hearing reports. This wasn't laziness or fear of hard work. It was a matter of status and dignity. In Roman culture, manual labor was fundamentally degrading for a free citizen, and especially for a member of the elite. Working with your hands marked you as lower class. Respectable citizens worked with their minds or not at all. They might own property, engage in commerce, though even this was somewhat looked down upon. hold public office, practice law, or live off the income from their estates. But they did not dig ditches or haul stones. This meant that elites experiencing road construction in their neighborhoods did so at a complete remove from the actual work. They might walk past the construction site, carefully avoiding dust and debris. They might complain about the inconvenience to other elites at dinner parties. They might observe the progress from the windows of their homes, but they would never, under any circumstances, participate in the physical labor. To do so would be to degrade themselves, to lose status, to become something less than what they were. Meanwhile, slaves performed the hardest physical tasks, their names lost to history, their contributions unrecorded and unremembered. We don't know the names of the men who cut the basalt in the quarries, who hauled stones through the streets of Pompeii, who fitted the paving stones that tourists walk on today. We never will. Enslaved people were considered property, tools that happened to be alive. Their labor built the city, but they received no credit, no recognition, no thanks. This erasure was systematic and intentional. When inscriptions commemorated road construction, they mentioned the magistrate who oversaw the work, perhaps the wealthy patron who funded it. They never mentioned the workers who actually did it. When histories were written, when documents were created, the enslaved laborers who built Rome's infrastructure were rendered invisible. This wasn't an oversight, it was policy. Acknowledging slave contributions might suggest that slaves deserved recognition, gratitude, even compensation. Far better, from the perspective of slaveholding societies, to simply pretend the work happened without human agency, or with only the agency of elite men who directed it. Yet despite this systematic devaluation, public works like road construction increased loyalty to Rome, demonstrating that Roman rule brought tangible benefits. This is one of the central paradoxes of the Roman Empire. The system was brutal, exploitative, and deeply unequal. And yet, it also provided things that people genuinely valued: peace, order, infrastructure, economic opportunity. For people who remembered or heard stories about the chaos and conflict before Roman rule, the benefits might outweigh the costs. Good roads meant easier travel, safer commerce, better drainage, reduced flooding. They meant a more pleasant urban environment. They meant economic opportunity. Shops on well-paved streets attracted more customers. Properties in well-maintained neighborhoods commanded higher values. For free citizens, even those who weren't wealthy, these were real benefits that made life measurably better. So Roman rule, for all its injustices, generated a degree of genuine loyalty. People might grumble about taxes, might resent particular officials, might complain about specific policies. But overall, many genuinely believed that Roman rule was preferable to the alternatives. And infrastructure improvements like road construction reinforced that belief. Every time they walked on a well-paved street, every time they successfully navigated through a rainstorm without wading through mud, they had tangible evidence that Roman rule brought benefits. Roads facilitated public ceremonies and processions, providing stages for the rituals that bound communities together. Roman religion was fundamentally public and communal. Yes, people had household shrines and performed private devotions, but the heart of Roman religious life was public ritual. Sacrifices performed before crowds, processions through streets, festivals that involved entire communities. Good roads made these ceremonies more impressive and effective. Picture a religious procession moving through Pompeii, priests in their ceremonial garments carrying sacred objects, musicians playing flutes, and streets were also venues for political ceremonies and civic celebrations. A triumphant magistrate might process through the streets to the forum. A victorious general might be honored with a public celebration. Important visitors might be given elaborate welcomes. All of these events depended on the streets being suitable stages for public performance. The streets weren't just transportation infrastructure. They were theatre, spaces where the drama of civic life played out before an audience of citizens. Religious rituals might bless major construction projects before they began, seeking divine favor for the work ahead. Romans were deeply religious, but in a very practical way. They believed that divine favor could be secured through proper ritual, and that divine disfavor could cause projects to fail. So before beginning major construction, it made sense to perform appropriate rituals, seeking the blessings of relevant deities. For road construction, the appropriate rituals might involve sacrifices to gods associated with travel, commerce, and craftsmanship. Prayers might ask for good weather, safety for workers, successful completion of the project. The rituals would be performed by a priest, probably with magistrates, and perhaps the donor present, possibly, with workers observing. After the rituals, work could begin with confidence that divine favor had been secured. These rituals served practical purposes beyond their religious function. They marked the official beginning of the project, signaling to the community that work was starting. They brought together the various stakeholders, magistrates, donors, workers, priests, in a shared ceremony that emphasized their common purpose. And they created a sense that the project was important enough to merit divine attention, elevating it beyond mere mundane construction work. Construction days followed Roman work calendars with their complex mix of work days, market days, and festivals. The Roman calendar was far more complicated than our simple 7-day week. Days were classified as either fastus, nefastus, or other categories that dictated what activities were appropriate. Some days were business days when legal proceedings and public business could be conducted. Other days were religious festivals when work was prohibited or restricted. Market days occurred on regular 8-day cycles, bringing crowds into the city. Construction schedules had to navigate this complex calendar. Work couldn't proceed during major festivals. It would be impious and might anger the gods. But magistrates also wouldn't want construction to interfere with. Market days, when streets needed to be accessible for commerce. So construction might pause every 8 days to allow market traffic through, then resume after the market day concluded. Rest days aligned with festivals, giving workers occasional respite from brutal labor and maintaining the rhythm of Roman religious life. These weren't days off in our modern sense. They were holy days when work was religiously prohibited. Workers didn't choose to rest. Rest was mandated by religious law, but the effect was the same. Regular breaks from the grinding physical labor of construction. The frequency of these rest days varied depending on the time of year and the particular festival celebrated. Some months might have several festival days, others fewer. Overall, the Roman calendar included numerous festivals throughout the year, probably resulting in 1 or 2 rest days per week on average. This was both permeated Roman life. There was no separation between sacred and secular, no distinction between religious and civil life. Everything existed within a framework of divine oversight and religious obligation. Even something as mundane as paving a street had its religious dimensions, its proper rituals, its holy days that had to be observed. This wasn't superstition from a Roman perspective. It was simply how the world worked, and to ignore religious requirements was to court disaster. Maintenance and longevity, the long view. Once built, roads required ongoing attention, and this ongoing maintenance reveals another important aspect of Roman urban management. Building a road was a major project that might happen once in a generation for any given street. But maintenance was constant, year after year, decade after decade, a never-ending cycle of inspection, repair, and renewal. Regular maintenance was essential. Even the best-built roads couldn't survive decades without care. The forces working against road surfaces were relentless. Heavy carts grinding stones together, working at joints slowly, crushing softer materials, water seeping into cracks, freezing in winter, expanding and creating fissures, roots growing under streets, pushing upward, disrupting paving, earthquakes, not uncommon in this volcanically active region, shaking foundations and dislodging stones. Without regular attention, even a perfectly constructed street would deteriorate. Small problems would become large ones. A single loose stone would allow water to penetrate, weakening the foundation beneath. Adjacent stones would loosen. Soon, a whole section might need replacement. Regular inspection and prompt repair prevented this deterioration cascade, keeping minor problems from becoming major failures. Damaged stones were replaced individually, pulled up, and new ones fitted in their places. This piecemeal repair approach made sense economically and practically. Rather than repaving entire streets when damage occurred, workers would identify and replace just the stones that needed it. A stone cracked by a heavy load, a section. Loosened by water damage, paving disrupted by tree roots. These could be addressed individually without tearing up large areas. The process of replacing individual stones required skill similar to the original paving work. Workers had to remove the damaged stone without disrupting surrounding stones, prepare the foundation beneath, select or cut a replacement stone that would fit properly, and install it so it sat at the correct height and angle. Well done. Repairs were nearly invisible, blending seamlessly with the original work. Poor repairs created bumps or depressions in the street surface, often becoming worse problems than the original damage. Over time, cart ruts began to guide future traffic patterns, creating grooves that directed wheels into familiar paths. If you visit Pompeii today and look at the streets, you'll see these ruts clearly, deep grooves worn into. The basalt paving by generations of cartwheels following the same paths. These ruts tell us enormous amounts about ancient traffic patterns, about which routes were most heavily used, about what kinds of carts traveled which streets. The depth of ruts also tells us about the volume and weight of traffic. Heavily trafficked commercial streets show deep, pronounced ruts. Residential side streets might show shallow ruts or none at all. And interestingly, than to climb out of them. This self-reinforcing pattern created both benefits and problems. On one hand, consistent rut patterns meant that repair work could focus on maintaining those specific areas. On the other hand, the concentrated wear in rut lines accelerated deterioration there, requiring more frequent maintenance. Some streets eventually needed complete resurfacing because the ruts had become so deep that the street surface was compromised. When properly maintained, streets lasted decades or even centuries, becoming permanent features of the urban landscape that outlived the buildings alongside them. This longevity is remarkable when you consider the stress these streets endured. Thousands of footsteps daily, hundreds of cart passages, weather extremes, occasional earthquakes. Yet some Pompeian streets were functioning for 200 years or more before the eruption of 79 AD, and they're still largely intact today, 2 millennia later. This longevity wasn't accidental. It was the result of good initial construction combined with consistent maintenance. Streets that were built well and cared for consistently could last indefinitely. The oldest streets in Pompeii, some dating back to the city's earliest periods as a Roman colony, were still in use when Vesuvius erupted. They had seen generations of Pompeians walk on them, had supported centuries of urban life, and would have continued functioning if the eruption hadn't buried them. But poor maintenance caused flooding problems as blocked drains turned streets into rivers during rainstorms. The sophisticated drainage systems that Roman engineers built into streets only worked if they were kept clear. Drains could become blocked by accumulated sediment, by debris washed in during storms, by trash carelessly dumped, even by plant roots growing into the drainage channels. A blocked drain meant water couldn't flow where it was supposed to go, and the result was flooding. Picture a heavy rainstorm hitting Pompeii. Water cascades off roofs, runs down streets, flowing toward drains as engineers intended. But if drains are blocked, the water backs up, pooling in streets, rising higher and higher. Soon, water is flowing into shops and homes at street level. Goods are damaged, floors are flooded, walls wick up moisture and weaken. After the storm passes, the standing water breeds mosquitoes and creates public health hazards, and the water that finally does drain away has been standing long enough to damage foundations and road surfaces. All of this could be prevented by regular drain maintenance, crews periodically clearing accumulated material from drains, ensuring water could flow freely. This unglamorous, messy work was essential to keeping the city functioning. Workers would use hooks and shovels to pull muck out of drains, probably a foul-smelling and unpleasant task. The material removed might be composted, dumped outside the city, or just piled until it could be carted away. But the work had to be done, and magistrates were responsible for ensuring it happened. In fact, magistrates could actually be fined for neglect of the roads under their authority, making infrastructure, maintenance a political as well as practical concern. This accountability system is fascinating and shows how seriously Romans took infrastructure. Magistrates were elected officials, serving limited terms, typically 1 or 2 years. But during their term, they were personally responsible for certain aspects of city administration, including road maintenance. Political career could be effectively ended by a reputation for incompetence or neglect. This created strong incentives for magistrates to take infrastructure seriously. They would appoint subordinates to oversee day-to-day maintenance, would allocate funds for repairs, would ensure that work crews were actually doing their jobs. But ultimately, the responsibility was theirs, and they knew it. This is quite different from many modern systems where responsibility is so diffused that no individual can be held accountable. In Roman Pompeii, if streets failed, everyone knew whose fault it was. When repairs were needed, reused original stone was used when possible, both for economy and to maintain consistency. This practice had multiple advantages. Stone from the same source as the original paving would match in color, texture, and hardness. It would weather similarly, and it was already paid for. When the street was first built, enough stone had been quarried and shaped to complete the job, often with some surplus. This surplus could be stored for future repairs, or old stones removed during repairs could be stockpiled for reuse. Reusing original stone also maintained the aesthetic consistency of streets. A street paved entirely with basalt from one source had a certain appearance. Repairs using stone from a different source might be visually obvious, creating a patchwork effect. While this wasn't necessarily a problem functionally, Romans cared about appearances. A uniform-looking street surface suggested competent maintenance and civic pride. A patchy-looking street suggested neglect or poverty. Streets evolved with city growth, sometimes widened or rerouted as neighborhoods expanded and needs changed. Cities aren't static. They grow, shrink, and transform over time. A side street that originally served a few residential properties might become important as the area developed. The street would need to be widened to handle increased traffic, or a street might need to be rerouted around new construction, diverted to improve traffic flow, or extended to connect with new developments. These modifications were more complex than simple maintenance. They required excavation, new foundation, work, additional paving, essentially building new street segments. They might require negotiating with property owners whose land was needed for the widening or rerouting. They required planning to ensure the modified street would integrate properly with existing streets, and they required the same political approval and funding as original construction. Some roads were even repaved multiple times over Pompeii's history, each generation renewing what earlier builders had created. Archaeological excavation has revealed streets with multiple layers of paving, one on top of another, showing how streets were maintained and improved over centuries. The lowest layer might date to early Roman occupation. Above it might be a layer from a generation or two later, when the street was considered worn enough to merit complete resurfacing. Above that might be yet another layer from later still. This layering tells us that Pompeians were committed to maintaining their urban infrastructure over the very long term. They weren't content to let streets deteriorate and become unusable. When a street reached the end of its useful life, they invested in rebuilding it, often building directly on top of the old surface rather than removing it. This strategy made sense. The old paving, even if worn, provided a stable foundation for new. Buildings collapsed under the weight. Roofs caved in, walls crumbled. But the streets, built low and strong, constructed to withstand weight and stress, largely survived. Today, archaeologists excavating Pompeii can walk on streets that are essentially as they were in 79 AD. The paving stones are still in place, still fitted tightly together. The drainage system still visible, still comprehensible. The cart rut still clear, still showing where ancient traffic rolled. This preservation is extraordinary and largely accidental. Vesuvius didn't care about preserving archaeological evidence, but the combination of good construction, the protective blanket of volcanic material, and luck means that we have an almost perfect snapshot of Roman urban infrastructure frozen in time. This allows modern engineers and archaeologists to study Roman road construction in detail impossible almost anywhere else. In cities that continued to be inhabited and developed, ancient streets were buried, destroyed, or so heavily modified that understanding original construction is difficult. But in Pompeii, we can see exactly how streets were built, exactly how they functioned, exactly how they integrated with other urban systems. We can walk in the footsteps of ancient Romans, literally following the same paths they did, feeling the same stones under our feet, and we can appreciate the skill and knowledge that created infrastructure durable enough to survive 2,000 years including a catastrophic volcanic eruption. Unique features of Pompeian streets. Pompeii had unique features that set its roads apart from other Roman cities, innovations and adaptations that solved problems specific to this particular urban environment. These features give us insight into how Roman engineers adapted general principles to local conditions, creating solutions that were practical, effective, and in some cases, quite ingenious. Perhaps the most distinctive and immediately recognizable feature of Pompeian streets is the stepping stones that allowed pedestrians to cross flooded streets without wading through water and waste. These raised stones, placed at intervals across street widths, are one of the most photographed features of Pompeii today, and for good reason. They're simultaneously practical and clever, solving a real problem in an elegant way. To understand why stepping stones were necessary, we need to understand the realities of ancient urban streets. Streets weren't just for transportation. They were also drainage channels, waste disposal systems, and sometimes open sewers. People would empty chamber pots into streets. Businesses would dump wash water and production waste into streets. Rain would wash all manner of debris from buildings and sidewalks into the street. Animals passing through would leave their contributions. The result was that streets, particularly in wet weather or after rain, could be flowing with a mixture of water, mud, sewage, garbage, and animal waste. Crossing such a street on foot meant either wading through this foul mixture or making an enormous detour to find a crossing point where the street could be navigated without soiling yourself. Neither option was appealing. The stepping stones solved this problem. Placed strategically across the street width, spaced so that an average person could step from one to the next, they created a dry path across even a badly flooded or filthy street, served both pedestrians, who used the stepping stones, and cart traffic, which rolled between them without conflict. The height of these stones matched cart axle widths precisely, a detail that required careful planning and measurement. This wasn't arbitrary. It was the result of understanding both pedestrian needs and cart design. The stones had to be high enough that pedestrians could cross above normal water levels in the street, but they couldn't be so high that cart axles would strike them. The clearance had to be just right, accounting for the height of typical cart axles and the diameter of cart wheels. This required standardization, both in cart design and in stepping stone construction. Carts in Pompeii must have been built to similar specifications, with axle heights falling within a relatively narrow range. Stepping stones had to be built to accommodate this range, high enough for their purpose, but not so high as to interfere with traffic. The fact that this system worked, that streets could handle both pedestrians and carts simultaneously without constant problems, suggests that Romans had worked out these details carefully. The wheel ruts created by countless carts are still visible today, worn deep into the volcanic stone, providing extraordinary evidence of ancient traffic patterns. These ruts aren't just shallow grooves. In heavily used streets, they can be several inches deep, cut into stone hard enough that modern tools would struggle to mark it. The fact that wooden wheels with iron rims could wear grooves this deep into basalt tells us something about the enormous volume of traffic these streets saw. Examining these ruts reveals fascinating details. You can see where carts turn corners, where ruts converge. From different streets, where the heaviest traffic concentrated, some streets show very deep, well-defined ruts, indicating heavy, frequent use over long periods. Others show shallower, less defined ruts, suggesting lighter traffic or shorter periods of use. archaeologists can use rut patterns to reconstruct ancient traffic flows, understanding which routes were most important for commerce, which streets connected key areas, which paths carts typically took through the city. The ruts also tell us about cart design. By measuring the spacing between parallel ruts, we can determine standard axle widths. We can see how carts navigated curves and intersections. We can identify places where carts waited, perhaps at street corners or outside particular buildings, where ruts are particularly deep from. Wheels sitting in one place while loads were being loaded or unloaded. These streets clearly reflect heavy commercial traffic, with wear patterns that tell us exactly which routes were most popular for transporting goods. Pompeii was a commercial city, its economy based on agriculture, fishing, trade, and small-scale manufacturing. Goods constantly flowed in and out, wine and olive oil from rural estates, grain from suppliers, fish from the coast, manufactured goods from workshops. This commerce required transportation, and that transportation left its marks on the streets. The deepest ruts appear on streets connecting the city gates to the forum and major markets, routes that saw constant commercial traffic. Streets in wealthy residential districts show lighter ruts. These areas saw fewer heavy carts. Industrial districts show moderate to heavy ruts, reflecting the movement of raw materials and advantage in road construction. Basalt from Vesuvius is an excellent paving material. Hard, resistant to weathering, good traction even when wet, and available locally. Some Roman cities had to import stone from considerable distances or use softer, less durable local stone. Pompeii could quarry high-quality paving material from nearby sources, reducing cost and ensuring quality. The durability of basalt is evident in how well Pompeii's streets have survived. 2,000 years after the last cart rolled over them, these stones remain largely intact, still fitted tightly together, still showing the wear patterns of ancient traffic, but otherwise little changed. Limestone or sandstone pavements from the same period have often eroded severely or been completely replaced. Basalt endures, resisting frost damage, chemical weathering, and mechanical wear far better than softer alternatives. Narrow streets limited speed, both for safety and to reduce noise in residential areas. This is an often overlooked aspect of Roman urban planning, the use of street width to control traffic behavior. Wide streets naturally encourage faster movement. Carts can spread out, find room to maneuver, build up speed. Narrow streets force slower, more careful movement. Carts must proceed single file, must navigate carefully to avoid hitting walls or other obstacles, must be ready to stop if they encounter oncoming traffic. In residential districts, narrow streets served multiple purposes. They slowed traffic, reducing noise and risk to pedestrians. They maximized the land available for buildings. Every foot of street width was a foot that couldn't be used for housing or shops. They created shaded areas. Narrow streets between tall buildings meant that sunlight reached street level for only part of the day, providing welcome relief from summer heat. And they created a sense of enclosure and intimacy that suited residential neighborhoods. Commercial districts might have wider streets to accommodate heavier traffic, but even these were narrower by modern standards. Ancient cities were pedestrian cities built on a human scale. Streets didn't need to be wide, enough for multiple lanes of traffic because there were no cars, no buses, no large trucks. The widest streets needed to accommodate two carts passing each other with room for pedestrians on raised sidewalks. That didn't. require much width by modern standards. Many roads doubled as drainage channels, their slightly concave surfaces directing water toward drains with remarkable efficiency. This dual function, transportation and water management, was essential in Mediterranean cities where rain can be torrential. The streets weren't just places to walk or drive carts. They were engineered channels for moving water out of the city before it could cause damage. The shape of the street surface was crucial to this function. As we discussed earlier, streets were crowned or cambered, higher in the middle than at the edges. But in some streets, particularly narrower ones, the entire surface might slope from one side to the other, channeling water toward a single gutter rather than dividing flow. Between two gutters, the slope was carefully calculated, enough to move water but not so steep that it would flow too fast and cause erosion or make the street difficult to navigate. Some streets were intentionally left uneven or difficult to navigate, and this was deliberate urban planning to control traffic patterns. Not all streets needed to be smooth and easy to traverse. Some streets were meant to discourage through traffic, to keep commercial carts out of residential areas, to force traffic onto main routes. Perhaps they'd use rougher paving or not pave at all. Perhaps they'd allow stepping stones to be placed in ways that made cart passage difficult. Perhaps they'd allow the street to develop ruts and irregularities without repair. The result would be that carters would avoid those streets unless they absolutely had to use them. Street design actively discouraged loitering carts, keeping traffic moving through commercial districts and preventing bottlenecks that could disrupt business. This is another example of using design to influence behavior. In busy commercial areas, stopped or slowly moving carts created problems. They blocked other traffic. They prevented customers from reaching shops. They created noise and confusion. But how do you keep carts moving without posting guards to chase away anyone who stops? Design solutions included narrow street widths that made stopping inconvenient because you'd block all traffic, curved street alignments that meant stopped carts weren't visible from a distance, reducing the appeal of stopping to display goods, lack of wide spots or pull-offs where carts could safely stop, and strategic placement of stepping stones that made it difficult for cars to stop without blocking pedestrian crossings. These subtle design features created an environment where the easiest thing to do was keep moving, delivering or picking up goods quickly, and then clearing out to make room for the next cart. The innovations developed in Pompeii influenced later Roman towns throughout the empire as administrators took what they learned here to other cities. Pompeii served as something of a laboratory for Roman urban planning. It was large enough to have complex urban problems, but small enough that solutions could be implemented and assessed relatively quickly. Magistrates and engineers who served in Pompeii might later take positions in other cities, bringing with them knowledge of what worked in Pompeii. Builders and craftsmen might move from city to city, spreading techniques and innovations. We can see Pompeii-like features in Roman cities throughout the empire. Stepping stones in Britain, similar. Drainage systems in North Africa, comparable street layouts in Spain. Some of this similarity reflects empire. Wide standards and training, but some of it represents specific transmission of innovations from one city to another, as people who had seen effective solutions in one place implemented them elsewhere. Pompeii's tragedy ensured its preservation, but its influence extended far beyond its own streets, shaping Roman urban planning throughout the empire and even influencing how we think about cities today. Pompeii in the broader context of Roman engineering. All of this existed within the broader context of Roman engineering excellence, and to truly appreciate what Pompeii's roads represent, we need to understand them as part of a larger story about Rome's relationship with infrastructure and the built environment. Road building was a hallmark of Roman engineering, one of the technologies that defined their civilization and marked them as different from, and in their own estimation, superior to, other ancient cultures. The Romans didn't invent paved roads, but they perfected them, standardized them, and deployed them on a scale never before seen. The famous long-distance highways, like the Via Appia, represented the most visible examples of recognizably Roman wherever you went. This infrastructure network was a major factor in Rome's ability to administer such a vast empire. It allowed for rapid communication, efficient military movement, commercial integration, and cultural exchange on an unprecedented scale. Road building techniques were shared across the empire through the movement of military engineers, administrators, and skilled workers, creating a remarkably consistent approach to infrastructure despite enormous geographic and cultural diversity. This knowledge transmission happened through multiple channels. The Roman military was perhaps the primary vector. Legions built roads wherever they went, training soldiers. In construction techniques, when soldiers retired, they often settled in frontier regions or returned to their home cities, carrying construction knowledge with them. Military engineers who designed fortifications and siege works also knew how to build roads, bridges, and aqueducts. These skills were transferable, and engineers might be reassigned from military to civilian projects, or vice versa. An engineer who had built roads for the army in Germania might later oversee civilian road construction in Gaul. An engineer who had worked on the aqueducts of Rome might be sent to build water systems in Spain. This constant movement of skilled personnel ensured that best practices spread throughout the empire. But knowledge also spread through more informal networks. Builders and craftsmen traveled seeking work, following construction booms, and moving where their skills were valued. A skilled stonecutter who had worked in Pompeii might hear about major construction happening in another city and travel there seeking employment. He'd bring with him knowledge of Pompeian techniques, perhaps introducing innovations to a new region. Over time, this created a sort of pan-imperial construction culture where good ideas spread and became standardized. Yet urban streets differed significantly from military highways. They served different purposes and faced different challenges that required adapted solutions. Military highways were built to move armies and supplies quickly across long distances. They needed to be straight when possible, to have gentle grades that wouldn't exhaust marching soldiers, to be wide enough for columns to march without bunching up, to be durable enough to handle heavy military traffic, including supply wagons and siege engines. Urban streets had different requirements. They needed to navigate around existing buildings and property lines. You couldn't just demolish half a city to create a straight street. They needed to integrate with complex drainage and water systems. Military highways could often just drain to the surrounding countryside, but urban streets had to channel water carefully to prevent flooding. They needed to serve mixed traffic, pedestrians, small handcarts, delivery wagons, animals, not primarily military columns, and they needed to function as public spaces for markets, ceremonies, and social interaction, not just transportation corridors. So while the fundamental techniques of road building translated from highways to urban streets, the application required significant adaptation. Engineers had to be flexible, adjusting their approach based on local conditions, existing infrastructure, topography, and intended use. The best engineers understood the principles deeply. Small provincial towns might show Roman influence, but often lacked the full range of urban infrastructure and amenities. Pompeii was just right, large enough to have all the standard features of a Roman city, small enough to be comprehensible as a single system. With a population estimated at perhaps 10 to 15,000 people, Pompeii had all the institutions and infrastructure you'd find in larger cities, just at a more manageable scale. It had a forum, theatres, anish, amphitheatre, numerous temples, public baths, a full network of streets and drainage, commercial districts, industrial areas, and residential neighbourhoods of various qualities. Studying Pompeii gives you a complete picture of how Roman urban systems worked, how the pieces fit together, how a Roman city functioned as an integrated whole. This is why Pompeii has influenced our understanding of Roman urbanism so profoundly. When scholars first began excavating the city in the 18th century, they were essentially uncovering a complete Roman town, preserved in extraordinary detail. Everything they learned about Pompeii helped them understand other Roman sites, creating a framework for interpreting fragmentary evidence elsewhere. Even today, discoveries in Pompeii continue to reshape our understanding of the Roman world. Roads reinforced Rome's administrative control, creating infrastructure that made governance easier and more efficient in ways both obvious and subtle. At the most basic level, good roads meant that Roman authorities could move quickly to address problems. If a city experienced unrest, if bandits threatened travelers, if natural disaster struck, Roman officials could respond rapidly. This responsiveness was part of how Rome maintained control over such a vast territory. People knew that Roman authority was real and effective, not just theoretical. But roads also facilitated the daily business of governance. Tax collectors traveled on Roman roads to gather revenue. Magistrates moved between cities on official business. Censuses were conducted more efficiently. When census takers could travel easily, imperial edicts and laws were distributed more quickly when messengers had good roads to travel on. All of this meant that Roman rule was more effective, more present in people's lives, more difficult to evade or ignore. The economic benefits of good roads also reinforced Roman control. Roads facilitated trade, and trade created wealth, and wealth created stakeholders who benefited from Roman rule and would oppose threats to it. Merchants who grew rich from commerce along Roman roads had strong incentives to support the system that enabled their prosperity. Cities that flourished economically because of their position on road networks had reason to stay loyal to Rome. The infrastructure itself created a network of interests aligned with the continuation of Roman power. Construction knowledge was passed orally from master to apprentice, with very little written down in technical manuals or treatises. This oral tradition had both strengths and weaknesses. The strength was that it allowed for nuanced contextual teaching. A master builder didn't just teach techniques. He taught judgment, adaptation, problem solving. He could point to a specific situation and explain why this approach worked here, but wouldn't work somewhere else. He could demonstrate the feel of properly compacted foundation, the sound of a well. Empire's decline couldn't build roads to the standards of earlier periods. They might try to maintain or repair older roads, but they couldn't reproduce them. The knowledge had been lost when the chain of transmission broke. This is one of the great great tragedies of Rome's fall in the West. Not just the political collapse, but the loss of accumulated technical knowledge. Skills that took centuries to develop were lost in generations. And because so little was written down, it couldn't easily be recovered. Later Europeans looking at Roman infrastructure couldn't understand how it was built. The knowledge had to be painstakingly rediscovered through experimentation and study of surviving examples. Roads connected civic, religious, and commercial spaces, shaping how citizens moved through their city and how they understood urban geography. The layout of streets wasn't arbitrary. It reflected and reinforced the city's priorities and values. In Pompeii, as in other Roman cities, major streets connected important nodes: the Forum, center of civic and commercial life; temples, religious centers; theaters and amphitheaters; entertainment venues; baths, social and hygienic facilities; gates, connections to the outside world. This street network created a mental map that residents internalized. You knew that to get from your home to the Forum, you'd follow certain streets. To reach a particular temple, you'd take a different route. The paths became so familiar that you could navigate them almost without thinking. But these habitual routes also shaped how you experienced the city, the shops you passed daily, the neighbors you encountered, the public spaces you crossed. All of these became part of your routine, shaping your social networks and your sense of place. Street layout shaped daily social interaction in profound ways. Who you encountered, what you saw, where you could easily go, and where required effort. In a city like Pompeii, where many people lived their entire lives, within a relatively small area, these patterns mattered enormously. Social class, for instance, was often reflected in residential location. The wealthy might live in large houses on major streets or in quiet residential districts with good drainage. The poor might occupy cramped quarters on back streets in flood-prone areas. The streets you regularly used revealed something about your social status and your daily activities. A wealthy woman traveling to the baths might use major streets, perhaps carried in a litter, passing through the busy commercial districts but separate from the crowds. A laborer walking to a construction site might use back streets and alleys, avoiding the congested main routes. A merchant might spend his day moving between his shop, the Forum, warehouses, and the homes of clients, creating a circuit that other merchants might share, but that would be foreign to people in other occupations. In all of this, Roman roads emphasized function over aesthetics, though the best examples achieved both through elegant simplicity. Roman engineers weren't primarily concerned with making beautiful roads. They wanted roads that worked, that lasted, that served their purposes efficiently. But there's a beauty in good function, in clean lines and honest materials, in structures that do exactly what they're supposed to do, without pretension or excess. And today, Pompeii's preserved streets remain a key archaeological source, offering insights into Roman urban life that we simply cannot get from cities that continue to evolve and destroy their ancient infrastructure. This is perhaps the final and most important context for understanding Pompeii's roads. In Rome itself, in most Roman cities that survived and grew into modern times, ancient streets have been built over, destroyed, modified beyond recognition. We can study them archaeologically, excavating beneath modern cities to find ancient remains, but we get only fragments, incomplete pictures. In Pompeii, we get the whole picture. Here, frozen in time by the eruption of 79 AD, we can walk on intact. Roman streets, see how they connected buildings, examine the drainage systems, measure the stepping stones, study the cart ruts, understand the complete urban system in a way that's impossible almost anywhere else. Every detail that would have been worn away, covered over, or destroyed elsewhere is preserved here for us to study. Pompeii has taught us how Roman streets were built, how they were used, how they aged and were maintained. It has shown us the relationship between streets and other urban infrastructure. It has revealed the daily reality of ancient urban life in ways that texts alone could never convey. And it continues to teach us. New excavations and new analytical techniques constantly reveal new information, adding to our understanding of how Romans built and lived. The streets of Pompeii are thus more than just archaeological remains. They're a precious window into the past, a direct connection to the ancient world that we can still walk on, touch, and experience 2 millennia after they were built. Every stone tells a story, every rut records ancient movement, every drain speaks to engineering. Knowledge, both sophisticated and practical. Here, frozen in time by disaster, we can still walk the same streets Romans walked, studying every detail of their construction and use, learning from them still. Conclusion. And there we have it. 100 remarkable insights into how the Romans built the streets of Pompeii, a city that would become one of history's greatest time capsules. What strikes me most about this story is the incredible contradiction at its heart. These roads were built by people whose names we'll never know, using techniques that were never written down, working under conditions we would find intolerable today. And yet their work has outlasted empires. Those basalt stones fitted so precisely by eye and hand have endured earthquakes, the catastrophic eruption of Vesuvius itself, and 2,000 years of weathering. They still bear the wheel ruts of carts that rolled through streets when Rome ruled. The world. Every stone tells a story of human ingenuity, but also of human cost. Behind every perfectly engineered drainage system was an enslaved laborer hauling volcanic rock in the summer heat. Behind every street that world, channels for commerce and culture, frameworks that shaped how people lived, worked, and interacted. When you walk the streets of Pompeii today, you're not just walking on old stones, you're following the paths that determined which merchants thrived, which neighborhoods flooded, which temples received processions, and which gates welcomed travelers from distant lands. The preservation of these streets is an extraordinary gift to us. Pompeii's tragedy became archaeology's treasure, giving us a level of detail about Roman urban life that exists almost nowhere else. Those stepping stones, those wheel ruts, those drainage channels, they're not just artifacts. They're answers to questions we're still asking about how to build cities that work, how to move water where it needs to go, how to create infrastructure that lasts. As we face our own infrastructure challenges in the modern world, there's something humbling about standing on a Roman road that's functioned for over 2 millennia. Our asphalt cracks after decades, our concrete crumbles, but basalt stones, fitted by hand and eye, endure. Thank you for joining me on this journey through the streets of ancient Pompeii. I hope you've gained not just knowledge, but appreciation for the workers who built these roads, for the engineers who designed them, and for the accidents of history that preserved them for us to study, admire, and learn from today. The roads of Pompeii still have stories to tell. We just have to be willing to listen.